8.2 goes over graphing functions in the form of ax squared plus c. With this c value, it's going to be after that a times x squared, so that variable raised to the second power. And it just means that you have a transition up or down from the original point of your vertex, which is normally 0, 0. So again, that plus a number just means it goes up. That vertex is going to be going up that many times, or the minus a number after the x squared is going to just mean that it goes down that many times. If we are looking at the first set of examples, it tells us to graph each function using the function table provided. So for example A, we're given g of x is equal to x squared minus 2. This minus 2 that's at the end of this x squared just means that that parabola is going to have a vertex that is at negative 2 on the y-axis. So it goes from that 0, 0 down 2 values. If we picked values for x and substituted in, I choose negative 2, negative 1, 0, 1, and 2. So we're going to have negative 2 squared minus 2, negative 1 squared minus 2, 0 squared minus 2, 1 squared minus 2, and 2 squared minus 2. The negative 2 squared is 4. 4 minus 2 is 2. We're going to get the same thing when we do 2 squared, positive 2 squared, minus 2. Negative 1 squared is 1. 1 minus 2 is negative 1. So we're going to get the same thing with 1 squared minus 2, which is negative 1. 0 squared is 0. 0 minus 2 is negative 2. So these ordered pairs that we have are going to be negative 2, positive 2, negative 1, negative 1, 0, negative 2, 1, negative 1, and 2, 2. So we graph these points on our coordinate plane now. So negative 2, 2 is going to be here. Then we have negative 1, negative 1, negative 1, negative 1 is here. 0, negative 2, 1, negative 1, and 2, 2. We draw our line through these ordered pairs. And then we're done. If we were asked to find a domain and range for this function, now these differ a little bit from your 8.1 lesson, where your domain, like we said with any parabola, is all real numbers. Your range, however, are the y values that are being covered. So your lowest y value is at negative 2, and it opens up, so that's y is greater than or equal to negative 2. For example 2, we're given g of x is equal to x squared minus 5. I choose values of negative 2, negative 1, 0, 1, and 2. This minus 5 after that x squared just means that we're going to start at 0, negative 5. That's what our vertex is going to be. If we plug in these values, we'll have negative 2 squared minus 5, negative 1 squared minus 5, 0 squared minus 5, positive 1 squared minus 5, and positive 2 squared minus 5. The negative 2 squared is 4. 4 minus 5 is negative 1. The negative 1 squared is 1. 1 minus 5 is negative 4. 0 squared is 0, minus 5 is negative 5. Again, the 1 squared minus 5 is going to give us negative 4, and then 2 squared minus 5 gives us negative 1. So these ordered pairs that we have to graph are negative 2, negative 1, negative 1, negative 4, 0, negative 5, 1, negative 4, and 2, negative 1. On the coordinate plane, we graph these ordered pairs. The negative 2, negative 1 is going to be here. Then we have negative 1, negative 4, 0, negative 5, positive 1, negative 4, and 2, negative 1. So this one, we're going to draw the line through these ordered pairs. Put our arrows. We'll realize that you see how that vertex goes down 5 units and is at negative 5 on the y-axis. If we're asked to state the domain and range for these, the domain, again, we have a parabola. It's all real numbers. Your range. This parabola opens up. Your lowest value is -5 on the y-axis. So we have y is greater than or equal to -5. For example C, we have h of x is equal to x squared plus 3. This one, we have a plus 3 after that x squared. So this just means that we're going up 3. We're moving up 3 for this graph. This is going to be a plus 3, not a -5. So we applied that change, and then we're going to plug in these numbers for x. So we have -2, -1, 0, 1, and 2. So we're going to have -2 squared plus 3, -1 squared plus 3, 0 squared plus 3, +1 squared plus 3, and 2 squared plus 3. The -2 squared is 4. 4 plus 3 is 7. -1 squared is 1. 1 plus 3 is 4. 0 squared is 0 plus 3 is 3. 1 squared plus 3 is 4. And 2 squared plus 3 is 7. So the ordered pairs that we have here are going to be -2, 7, -1, 4, 0, 3, 1, 4, and 2, 7. So on this coordinate plane, when we draw our points, we have -2, 7, which is here. Then we have -1, 4, 0, 3, 1, 4, and 2, 7. We draw a line through those points, making sure that we have a curve that's happening. And then we can state our domain and range. Our domain for this one, again, we have a parabola, so it's all real numbers. Our range, that parabola opens up. Our lowest value that's on that y is at 3, so y has to be greater than or equal to 3. For example B, we are given g of x is equal to 2x squared minus 5. So for this one, again, I'm going to use values of -2, -1, 0, 1, and 2. We're going to have 2 times -2 squared, 2 times -2 squared minus 5, 2 times -1 squared minus 5, 2 times 0 squared minus 5, 2 times +1 squared minus 5, and 2 times +2 squared minus 5. From here, that -2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. The 1 squared or the -1 squared is 1 times 2 is 2. 2 minus 3, 2 minus 5 is -3. The 0 squared is 0 times 2 is 0 minus 5 is -5. The 1 squared is 1 times 2 is 2. 2 minus 5 is -3. And 2 squared is 4 times 2 is 8 minus 5 is +3. So we have ordered pairs of -2, 3, -1, -3, 0, -5, 1, -3, and 2, +3. Graphing these ordered pairs, the -2, 3 is going to be here. Then we have -1, -3, 0, -5, 1, -3, and 2, +3. So we draw these lines, or this line through these points, stating our domain and range. Our domain is all real numbers. Our range is y is greater than or equal to -5. If we look at example C, we're given h of x is equal to -1/4 x squared plus 4. I chose the values -8, -4, 0, 4, and that's supposed to be an 8. So all right. If we plug in these values, we're going to have negative 1/4 times negative 8 squared plus 4. Negative 1/4 times negative 4 squared plus 4. Negative 1/4 times 0 squared plus 4. Negative 1/4 times 4 squared plus 4. And negative 1/4 times 8 squared plus 4. I'm going to add on negative 2 and positive 2 with these, just so that way I have a better idea of where my parabola has points. That negative 8 squared is 64. 64 divided by negative 4 is negative 16. Negative 16 plus 4 is negative 12. The negative 1/4 times 4, negative 4 squared is 16 divided by negative 4, which is negative 4, plus 4 is 0. The 0 squared is 0, divided by negative 4 is 0, plus 4 is 0. Is 4. The negative 1/4 times 4 squared plus 4 gives us 0. The negative 1/4 times 8 squared plus 4 gives us negative 12. The negative 1/4 times negative 2 squared plus 4. The negative 2 squared is 4, divided by negative 4 is a negative 1, plus 4 is 3. And we're going to get a 3 for the positive 2 as well. So this is giving us ordered pairs of negative 8, negative 12, negative 4, 0, 0, 4, positive 4, 0, positive 8, negative 12, negative 2, 3, and positive 2, 3. So that negative 8, negative 12 is going to be right here. Then we have negative 4, 0, which is here. 0, 4 is here. 4, 0 is here. And 8, negative 12 is here. If we wanted to add in that negative 2, 3 and that positive 2, 3, we would just be here and here. So if I was to draw the line through these ordered pairs, my parabola would look like this. My domain, since I have a parabola, it's all real numbers. My range, my highest value here, since this parabola opens down, is going to be at that 4. So y is less than or equal to 4. For the next part of your lesson, you're describing the transformations from the graph of f of x to the graph of g of x. And then it asks you to graph each function on the same coordinate plane. Now, with these, I'm not going to require you to graph these. I just want you to explain the transformation that's happening from one to the other. And the way that we're going to do this is we're going to apply the rule that they're giving us. So they tell us that g of x is equal to f of x minus 7. However, they give us f of x is equal to 0.5x squared plus 2. So we are just going to take this 0.5x squared plus 2, plug it in where you see the f of x in g of x. So what does this mean? G of x is equal to f of x, which we said was negative 0.5x squared plus 2 minus 7. If we got rid of these parentheses, we'd have negative 0.5x squared plus 2 minus 7. If we combined our like terms here, we would have g of x is equal to negative 0.5x squared minus 5. So how do these two functions differ? Well, f of x has that plus 2. So it goes up 2 units. G of x has that minus 5. That means it's going down 2 units. So these both have the same a value with them. That's not changing. The only thing that changes with them is whether or not they go up 2 units or down 5 units. For example, B, they're telling you that f of x is equal to 3x squared minus 1, and g of x is equal to f of x plus 3. Well, f of x, it tells you, is that 3x squared minus 1. You have f of x in your g of x, so just replace f of x with that 3x squared minus 1. So g of x is equal to f of x, which is 3x squared minus 1 plus 3. Get rid of your parentheses. You have g of x is equal to 3x squared minus 1 plus 3, and combine your like terms. So g of x is equal to 3x squared plus 2. Now, what's the difference between these two functions? Well, f of x has that minus 1, which means it goes down 1 unit. G of x has the same same a value, which is at 3 in front of the x squared. However, you have plus 2, so that means it goes up 2 units.